So thank you all for joining this Snack and Learn webinar. My name is Isis, and I'm a structural engineer working out of our Ottawa, Canada office. And for the past 2 years, I've been focused on steel reuse. So today I'm going to walk you through this guide to designing with reused structural steel, and we're taking this from the source material to the construction drawings. So my main message today is that reused steel is more practical than you might think. And we're going to get started with a brief introduction to reuse. Going to look at the case study that I've been working on. And we're going to take a look at the source material, how to design with it, and the potential for automation. And like I said before, we have Q&A at the end. So why in the world would we want to reuse steel? So in a typical project, when we're deconstructing a building and all of that steel is now discarded, it's actually going into the recycling stream. And when we recycle our steel, we have to melt it down, and that accounts for about 95% of the steel's embodied carbon in that final product. So if, as the designer, we can decide to reuse the steel and skip that step, we can make a big impact to the embodied carbon of that steel, but also the broader building, because steel is in the top 2 contributors to the overall building's embodied carbon. It's up there with concrete. So for anybody who's starting working with steel reuse, I would highly recommend this guide I'm showing here. It's called the guide SCI P427. And this will be linked in the email that follows up this presentation. So this guide comes from the UK, and it highlights the responsibilities for who is documenting this reused steel, how it should be inspected. And this is in the UK context, but it's important for anyone working with reused steel because it highlights everything that you need to consider as part of the process. It also lets you know what steel should be excluded from reuse. So this would be steel that's been exposed to fatigue over its life. So this could be steel that came from a bridge. There's also guidance on how to design with the steel. So when you're working with a beam, you can design a reused steel beam just like a new steel beam. But if you're looking at columns, there's some suggestions on strength reduction factors that I recommend you check out. So after you are familiar with that guide, it's important to take a look at the codes that govern in your area. So I'm working in Canada, so I'm going to speak to the CSA S16. So there's a provision here for unidentified structural steel. So this would be steel that has not been tested, and it could be in a building that's being renovated, but it could also pertain to steel that's been removed from the building and is being installed somewhere else. So in this case, you can look at a yield strength of 210 MPa for all of your design. Now that's a fairly low grade steel. So if you know you're working with more modern steel of a higher grade, there's also guidelines on how to test that steel. And from the designer's perspective, there's 2 sort of material life cycles. So the first one is if you're working with a donor building. So this is any building that's going to be demolished that you've identified for steel harvesting. So you want to take all of that steel out of that building, deconstruct the structure, inspect the steel to ensure it's good quality, and then you can create an inventory, and at that point get into your design and the new construction phase. Now some regions have steel suppliers that you can work with. So if you happen to have a steel supplier available to you, they'll take on the role of sourcing that steel, inventorying it, and assuring that it is good quality. So our colleagues in the UK are doing work in this realm, and I suggest you check that out. So the work that I've been focused on with my team in Ottawa is the Centre Block Rehabilitation. So this building here, Centre Block, is the main Parliament building for Canada, and it's undergoing a pretty major rehabilitation. So the Ottawa team is focused on the seismic upgrade of this building. So this whole building is being base isolated. That means it's essentially being cut at the interface between the ground and the superstructure. So in the event of an earthquake, the ground can move more freely and the stresses that are being sent up into the superstructure are much reduced, so the building will have better performance overall. The building is also being rehabilitated and modernized, and there's also going to be new public spaces put in so that people can have a new relationship with this building. And part of this rehabilitation, most of the steel in the building is remaining in place, but some of it is being removed. And that's the steel that we're using as part of this reuse steel program. So this is our donor building, but it's also where the steel is going to be installed afterwards. So this is a pretty atypical project for reuse steel because it does take quite a bit of time to remove the steel from the building, inspect it, make an inventory, and then bring it back to site for the new construction phase. But because there is significant basement works going on in this project, we have a schedule that allows us to do this as both the source of the steel and the destination for that steel. So a little bit more about this donor building. So this image here is from the 1917 construction, and this is actually the second construction of this building. The original one had burned down, and you can see this spire in the background. This is part of the original building. It's a library building that was saved from the fire. So this second construction is masonry building with steel structure inside. So the steel beams either connect to steel columns or they bear directly on the unreinforced masonry. And the floors are made out of terracotta. So this is a building typology that you wouldn't see today. So the rehabilitation project is going to result in over 2,000 beams being removed from the building and considered for reuse. And this volume of steel is going to result in over 500 tons of CO2 equivalents being saved from the embodied carbon. And that's a pretty significant measure. So whenever you're dealing with a reused steel material, it's best practices to assess this source material. It's not strictly necessary, but it's highly recommended. So this project has a pretty significant set of structural investigations, and this is because the majority of the steel is staying in situ in the original building and is not coming out. So this image here is from a structural investigation looking at the connections of these steel members in part of the building that is staying in place. So the reason for these investigations was to validate that what was found on site matched the historic drawings so that the steel remaining in place but under new loads could be designed with confidently. It also allowed for the inspection of corrosion or any damage that could be found, and also allowed for sampling of the steel for strength and weldability tests. So the tests for weldability came back as not readily weldable. So that informs our steel reuse program, where we've decided to go exclusively with bolted connections for all of the new connections for the reused steel, because it would be more difficult to weld them. There is also testing done of the steel coating. Now, the coating isn't visually apparent, but there is a coating there, and it came back as lead containing. And I'll touch on that again in a minute. So now that we have a good idea of the material that we're working with, we need specifications for working with the reused steel. So the first item is quite intuitive. If you're dismantling the steel and you want to reuse it, you're going to want the longest sections possible. But it's important that you specify that because a typical demolition specialist is going to want to work with the steel as easily as possible, cut it into small little pieces, and do their work that way. So you have to indicate that you want the cuts cut as close to the connections as possible, and any intermediary members framing in need to be removed. Once the steel is out of your building, it needs to be inspected for any cross-section loss due to corrosion. You need to limit any section losses due to penetrations. So this one I say limit, not exclude, because there might be mechanical openings through the web of your member or electrical conduits that were passed through, or any small holes from connections from beams framing into girders, which would cause some section loss that you might want to include as steel that you're going to reuse. It's also important to validate that the cross-sectional area that you're expecting is what is truly there in the reused steel beam, so that you have confidence when designing with the member that you're using the correct size. The steel will also need to be stored, and you'll need to inform your fabricator that you're working with reused steel so they know how you're managing the steel and what to expect. And in this case study, that means having all bolted connections. For the designated substances on this project, we're keeping the coating in place, but anywhere where there needs to be a cut for fabrication or for dismantling, there needs to be local removal of that coating, and that's to protect the worker when they cut into the member, and the coating could become airborne if it were not removed. So WSP in Canada is expanding the specification for this case study to generalize it for other projects. So if you're interested in using steel reuse on your project, please reach out for the specs. So when we design for these members, the way that we're doing it is we go through and design our building sort of business as usual. So go through for each beam, assign a modern size. And so that modern size will have capacities associated with it as well as a depth. So this is a 200 millimeter deep beam that's been chosen here. And once the new design is finished, you can then cross-reference all of those beams with your salvage steel inventory. So all the beams that have passed inspection. Then you check the capacities and ensure that all the capacities are equal to or greater. So you see for this beam, the governing capacity is the shear capacity. And you'll notice for this historic section, it's a 10-inch I-beam that's 25 pounds per foot. It's actually deeper than the new equivalent section. It's 254 millimeters. And this is typical for this case study because we're working with a lower grade steel. If you were working with a more modern steel, you probably would have equivalent beam depths, but this is something that we need to consider on this project. I would recommend for anybody who is doing a reuse steel project to do a demand-based match. So that's a bit different than what I just highlighted. So if you're doing a demand-based match, what you do when you're originally designing your building, you would skip the step where you pick out the modern equivalent steel size. So you would just list what the moment demand, the shear demand, and any serviceability requirements that you would have, and then directly cross-reference that with your salvage steel inventory. So this could give you a more efficient match because you're skipping that intermediary beam. Another thing to consider is with your reused steel beam inventory, you'll want to make any adjustments necessary for your steel condition. So if you've allowed for some small defects or some small openings in, say, the web of your member, anything that's allowed in the steel inspection phase should be considered in the design and how that affects your capacity. So our ultimate goal here is to go from a big pile of salvage steel and match that up with a destination in our new construction. So what I'm showing here is our beams in the construction drawing, where I'm showing two pieces of information. One is that new equivalent steel beam, and below it is a unique identifier for the reused steel member. So the reason that we're showing both is to speed things up during the installation phase. So if for some reason this beam 103 goes missing on site, or it's miscut, or there's an opening along the length that conflicts with the new connections that are being fabricated, the fabricator can reach out to us and ask us for an alternative section. So hopefully we'll find an alternative reused steel beam that's available. And if not, we can direct them to go purchase the equivalent new section. So that's the method that we're following, but how we're implementing it is another problem. So where do we reuse steel in this building? It's difficult to assign all of these matches manually when we're working with over 2,000 beams. We also want some method to optimize our steel reuse, and we want to quickly and clearly communicate this on our drawings. So our solution to this is to use an algorithm to do all of the matches automatically for us. So this is a big time saver. And we've also included a provision to limit the structural depth. So because we're working with this lower grade steel, whenever we're substituting in a reused steel beam for a new one, we're typically using a deeper section. And that could have some impact on the mechanical systems and architectural systems that are hanging below our structure. So we don't want any conflict there. So we're putting in a strict limit at each zone of the building. And we're optimizing our steel reuse by including in our algorithm the function to trim our beams. So we create our match, we trim our beam, and whatever steel is left over, that is put back into the inventory of steel beams to be reused elsewhere. So this is a good algorithm for this case study because the majority of the building is remaining in situ, and there are a lot of mechanical openings that are going in. So these mechanical openings drive a demand for shorter sections. And then we're communicating the results of this matching algorithm in our Revit model automatically. So the workflow looks like this. We have our steel beam inventory, which is all the beams that have passed inspection. We have our new steel inventory, which is automatically generated within Revit. These two sets of information are passed into our matching tool, which then outputs the results directly onto our construction drawings in Revit. So this is what it would look like. This is the same snip as earlier, but if you were to select this beam within the Revit platform, you would find some reuse steel specific parameters that we've added, which includes the maximum depth of the structure in this location, and it also includes the unique identifier for the reused beam that would be placed here, and this is automatically populated. So that's the full process of reusing the steel on this case study. The key takeaways that I do want to highlight is if you're going down the path of using a donor building, you need to get everyone involved very early because it does take time to get ownership of the steel, decide who's going to dismantle it, who is going to do the inspection, and get your specifications ready. I would recommend anyone going down this path to get creative. So in our case, using offcuts and using lots of short beams was a great method. Other methods might be preferable elsewhere. I would also recommend some flexibility in your structural layout. If you have a steel beam inventory that is all one length and your bays are just a little bit longer than that, it would be worth changing your structural layout to suit your available steel inventory and play around with span direction to optimize that there. As far as design automation, it's not strictly necessary to automate this design, but I'm a huge proponent of the automation, especially if you're working with large volumes of steel like we are on the Centre Block project. Also, if you have a matching algorithm, it could potentially give you better, more sustainable results. And if you're playing around with your structural layout and you can automate the matches, you can quickly assess different layouts and figure out which one is the best. Also, it's nice to have automated drawing tags so that nobody has to type in unique identifiers on your drawings, and it reduces errors there. All right, so that is all I have for you today. Thank you for your time, and I hope you consider steel reuse on your next project.
Thank you, Isis, for a fantastic presentation. So just some housekeeping items before we get going. The presentation slides are available to download in the handout box, and you can continue to log your questions in the question box on the control panel. So I will start with the first question. Is there a process to certify historic steel that is fire damaged or potentially fire damaged?
Yeah, so for fire damaged steel, I would be very careful with working with that. Just on this project, we don't have fire damaged steel. And if your steel has been exposed to high temperatures, it's going to reduce its strength and you're probably going to get some deformation. So any steel that has sagged or plastically deformed or had some warping or crippling, that would definitely need to be excluded from reuse. Fire coatings are touched on by the UK Steel Reuse Guide, and they clearly state that if there's any fire protective coating on the original steel, that you wouldn't want to rely on that. But as far as designing with steel that may have been in a fire or has been in a fire, you would need to do a deeper dive into the literature.
Thank you. What would be a key challenge in the incorporation of steel reuse within large sectors like construction?
Yeah, so in large sectors, I think the issue is getting an inventory set up that's not on a case-by-case basis. So for this project, we're working with a donor building. We have a limited inventory based on our donor building, and we have to work with that. As far as expanding this across the industry, we would want there to be salvage steel suppliers in every region that could supply steel to multiple projects.
Thank you. There's a question here about circular economy. Did you quantify the circular economy, carbon, or other sustainability benefits of the reuse? Could your algorithm be adapted to include this data, even if it's worst case scenario?
So yes and yes. So one of the first things we did was we reached out to our WSP internal sustainability team and asked them to do a life cycle assessment for the steel and look at the benefits of using the historic steel and reusing that versus just strictly buying new steel. So there was an even bigger sustainability benefit for this historic steel, and the embodied carbon for that is from entirely virgin metal. There's no recycled content. So by extending its life, we have a greater sustainability benefit. And as far as the algorithm, yes, we're looking at adding to our algorithm right now to quantify the benefit of each match. So ranking each match in the building based on the amount of steel that is being reused and having the most efficient match. So that is something that we are considering.
Thank you. There's a question here about the algorithm. Does the algorithm identify the type of framing member, for example, primary and secondary frame members?
No, it does not. It just looks strictly at the beam and tries to, well, not tries, does either match or exceed the capacity of that beam. We've looked into other tools that look at automatically identifying the trib width and identifying members as primary and secondary, but that is sort of beyond this project.
Thank you. A stakeholder engagement question. Do you have any tips for getting stakeholders on board? Any recommendation at what project size this approach become more reasonable to suggest?
Yeah, that's interesting. So bigger projects often have bigger budgets, more people involved who can potentially work on this, but I wouldn't shy away from this for smaller projects. There are some examples of smaller projects that have used just a couple dozen reused steel members, or there's another project in Ottawa that sent just a handful of deep beams to be extended. So they used the full section and added on a new piece of steel at the end to adapt it for the new use of the building. So I don't think there's any hard and fast rule for when this should be applied. I think on larger projects, there might be more appetite if it's a project that has sustainable goals strictly listed, like the one I'm working on.
Thank you. And next question is, are you aware of steel from other sectors, like for example, offshore wind being used in, like offshore winds? And the question is, can we use, do you have any challenges, barriers, and lessons learned from other sectors?
Yeah, so other sectors is pretty interesting. So offshore platforms, I would be worried that that steel has been exposed to fatigue, but I'm not an expert in those. But as far as anything that's been exposed to, like anything that's been in a plastic hinge, anything that has had any deformation, that should be excluded from steel reuse.
Thank you. How are you marking or tracking the salvaged beams?
Sure. So we're tracking the beams with a unique identifier, which we are pairing up with a barcode. So the barcodes that we're using are just these tiny little metallic barcodes that are then attached to the beams. And that system is tied into our digital inventory. So we can clearly scan the beam, know what size it is, know if it's passed inspection, just from scanning it.
Sir Isis, is everything okay?
Yeah, did I disappear for a second?
No, we can still see you.
Okay. I think I might have missed something you said then.
The question was for the marking or tracking the salvage beams.
Yeah, so we're using barcodes for that. And we're also tagging on, so we have a fairly long unique identifier, and we're tagging on to a pre-existing asset tagging strategy that we already have on this building, because there's quite a few heritage assets that are being removed from site and brought back later. So we're tagging along with that for both the naming strategy as well as our metal barcodes, which are tied back to our inventory.
Thank you. The next question is about the project. You mentioned this project is quite high profile. Is it beneficial to use in a smaller project to go through this process of automation?
So I think once you've set up the automation once, you can use it on multiple projects. So I think that reused steel is going to get more popular going forward. So I would suggest that it's reasonable to automate this. And for the initial version of this script, we didn't have any dedicated programmers. We started with a group of structural engineers who created the algorithm. And then later on, we pulled in more well-versed programmers to automate this. But I don't think it's a particularly daunting task. It takes a little bit of time, but if you can reuse the algorithm and matching tool on multiple projects, I think it would be worth your while.
Fantastic, thank you. We have many more questions that will be answered directly by Isis later on via email. So thank you everyone for joining us today. Please feel free to reach out to Isis via the contact details shown on the screen for any additional questions. So I would like to thank everyone for joining today. Thank you, Isis, for a fantastic presentation, and have a wonderful day, everyone. I will wrap up the session now.